Thanks so much to Fraser for organizing and to Leeds School of Art for hosting. So my paper is from a chapter I'm finalizing for an architectural history collection titled The Combinatorial Imperative, and the collection's being edited by Jennifer Mack and Pablo Miranda and is forthcoming from TU Delft and YAPSAM in the Netherlands. So, excuse me, for this presentation, I'm compressing 8,000 words into 20 minutes, so there is both omission and simplification. I've cut out most of the details of how the discussion connects back to architecture and streamlined certain theoretical details. I'm happy to pick up in more depth with anyone who's interested, and as requested, I'm going to be reading to keep things to time. So, the main focus is on two well-known typefaces designed by Adrian Frutiger, Univers, 1957, designed for use with early phototypesetting equipment, and OCR-B, 1968, developed for use with computerized optical character recognition. Both are notable for their attention to the capacities of humans in response to the emergence of new kinds of machines for reading and writing during the post-war period. My discussion of the typefaces provides a springboard for a broader cross-disciplinary consideration of human-computer interaction at the onset of electronic text. Frutiger was hired by Debeney and Pignot in Paris in 1952, just as they were beginning to work with Lumatype, an early Western example of phototypesetting. A 1960s model is pictured here on the left. The machine was first developed in 1946 by French electrical engineers René Igonet and Louis Moirou. During a visit to a linotype plant, the pair had observed how difficult it was to integrate hot metal with offset. They came up with an idea for a machine controlled by a keyboard, which would move and rotate a transparent disc containing letters and symbols through which a precise light would expose the correct characters onto a film plate, which could then be incorporated into offset processes. So in 1949, Igonet and Moirou relocated to Cambridge, Massachusetts, with the support of former scientific administrator for the US government, Vannevar Bush. Bush's influential 1945 article in The Atlantic, As We May Think, had envisioned a workstation called the MEMEX, an electromechanical device for storing, retrieving, and linking information. I'm going to come back to it a bit later. There's no direct technological connection between the Lumatype and the MEMEX. However, they share an interest in the use of film to pursue a high level of malleability in the manipulation of text. So, Univers is understood within typographic histories as implementing both a continuation and a critique of interwar typographic movements, including the new typography. These emphasized industrial paper sizes, sans serif typefaces, and geometric shapes, pursuing what was understood as clear communication unburdened by decoration or ornament. Amongst experiments with the idea of a geometrical typeface produced during this period, Futura, designed by Paul Renner in 1927, was considered to be the most legible, even if not the most purely geometrical. Because Futura, called Europe in France, persisted as Debeney and Pignot's best-selling typeface into the 1950s, Charles Pignot originally suggested it as the first sans serif for Lumatype in France. Frutiger, who found geometric typefaces to be insufficiently legible across spans of text, proposed his own sans serif instead. So in addition to eliminating the need for hot metal, Frutiger observed that the Lumatype's disk-based system brought with it new possibilities for the interchangeability of typefaces. So this is Frutiger reflecting back. The photon typesetting disks contained 8 rows with 2 fonts each, making 16 fonts altogether. With 12 possible point sizes, that meant that one disk had over 17,000 characters available at any time. One had a proper little composing room with fantastic possibilities for setting complicated typesetting and mixing type of any kind. Photosetting brought about far-reaching changes to the printing presses and composing rooms. One typesetting disk replaced many cases full of lead type, which weighed tons. Frutiger became interested in the formal potential of being able to move between different typefaces, variations, scales, and special characters with greater agility, either within a disk or by swapping disks. So the sans serif, which was later named Univers, was reconceptualized as a systematically unified family consisting of 21 weights and variations designed to be interoperable with one another. Rather than squares, triangles, and circles, it was constructed around a horizontal vertical axis against which its variations in weight, slant, and density are consistently hung. And Frutiger adopted the proportions of 19th century sans serifs, which themselves referenced Greek lapidary scripts, in addition to optimizing for readability. which required prioritizing relationships between letters more than the form of individual letters, this decision would allow for sufficient flexibility to sustain a consistent sense of proportion across the large family. So the presence of the human hand in Univers is reinforced by the adaptation of horizontals to terminate curved letters, so like C and S, for example, from an 8th century Anglo-Irish script. And there was an exception in the case of lowercase t, which set the pattern for F, J, and R. Frutiger said, quote, "The slanted cut of the T demonstrates my respect for writing with a pen." Reflecting back on a visit to the US, coinciding with the American release of Univers, Frutiger told a story about a technician who was searching for the algorithm underlying the design and disappointed to find out that none existed. He showed me a whole batch of films with Univers letters. He laid them on top of each other on a light box and confronted me with lots of calculations. He was looking for a mathematical connection between boldness and width and couldn't figure out how I'd calculated it. Some of his results coincidentally led to a connection with the golden section. When I told him that I had worked out the basic type grid by intuition, he was nonplussed, not to say disappointed. In this vein, Univers can be understood as a close study of the limits of rationalization from a human perspective. Frutiger argued that type should support visual play against a clear and robust communicative structure. Quote, "Modern concrete buildings aren't necessarily geometrical. Their forms have tension and liveliness. Type has to have these things too." And this, for him, was best accomplished through human discretion, which went beyond what could be achieved through simple engineering. Practice, drawing, and craft skills informed by historical precedents, cross-checking by eye and through measurement, and extensive testing. So Univers, despite its widespread use, has rarely been considered explicitly from beyond graphic design, and this is not unusual for a typeface. So print historian Beatrice Ward, as everyone knows, asserted that type well used is invisible, as type, just as the perfect talking voice, is the unnoticed vehicle for the transmission of words, ideas. So I realize that my notes have to be scrolled here. It may be that Ward's way of thinking was as consequential for the study of knowledge as it was for typography. So philosopher Jacques Derrida observed the alphabet, which is the most abstract and most powerful structure of writing, is also the most easily naturalized. It is the most invisible of scripts, the one we notice least, precisely because it is the one that has most thoroughly shaped our habits of thought. Because in alphabets there's a dynamic link between the written expression of a word and the way it sounds, the same set of symbols can be recombined to formulate any word. Where Ward saw the role of the graphic designer as one of removing friction from this process, Derrida argued against an understanding of the alphabet as merely a representation of phonemes, as this would detract from a reader's ability to be sufficiently sensitive to the meaningful characteristics of writing's own logic and structure. Derrida did not use the term fidelity, but provided a critique of the belief that writing can dumbly replicate meaning. This was later expanded upon by media theorist Friedrich Kittler, who argued that media do not transmit meaning faithfully. They transform, distort, and overwrite it. Derrida's contention regarding the role of the instability of writing in meaning-making sits in contrast to the kind of fidelity envisioned by Bush, whose vision of the memex, storing vast amounts of information, books, images, documents, depended on accuracy. Once something was recorded, the idea was that it could be accessed later exactly as it was without loss of detail or meaning. In her essay on the historical ontology of form, architectural historian Zeynep Çelik-Alexander, referring to examples including early experiments with telegraphy, and one of these is shown here, considers the implications for modernism of machines which desemanticize active reading, replacing it with, quote, gazing or scanning without any search for deep meaning. So here I am building on another chapter of mine from 2023, Situating Google's Alphabet, in which I explored Google's 2015 decision to rename itself Alphabet in the context of mid-20th century media studies claims regarding the significance and impact of the alphabet, especially those of media theorist Marshall McLuhan and later 20th century critiques of those debates on the grounds of their colonial presumptions. So McLuhan understands the alphabet as it relates to spoken phonemes as a kind of instigating scanning technology in Alexander's sense. This is in many ways the basis of his claim that the alphabet and the printing press heralded the development of electronic media. So what I'm working on in this new chapter is reattending to the alphabet, given the problematic way McLuhan depends on it through a typographic lens. As graphic designer and philosopher Sheena Calvert observes, typographers and other creative practitioners, quote, amplify or correct the work of text-based philosophers of language by drawing attention to those qualities of language that cannot be spoken or written about from within the discursive form. The same can be said of media and technology studies. McLuhan's arguments, which remain a significant point of inspiration for the tech industry, depend on his foregrounding of the alphabet as an initial phase in a process of mediation to which he argues fatalistically that human beings will become fully subject. Typography provides an especially productive basis to elaborate on recent feminist re-examinations of McLuhan's fatalism to destabilize the problematic way he appropriates and depends on the alphabet. So in the context of the volume on modularity to which I'm contributing, this work has led me to explicitly define and distinguish between two different kinds of modularity. In algorithmic modularity, the assembly and disassembly of components is fully automated. Algorithmic modularity is associated with the ideals of lossless transmission, which enact desemanticization, this term again borrowed from Alexander. McLuhan understood the alphabet as algorithmic exactly in this sense. In what I'm trying to reclaim from McLuhan, and implicitly Google as alphabetic modularity, there is a dialogue between humans and systems which produce new kinds of meaningful arrangements. Frutiger's considered engagement with early developments in electronic text contribute to strengthening the possibility of the alphabet as an example of an open, multiple, and adaptable system. He makes a typographic contribution to the denial by the alphabet of the ideal of lossless transmission in a way that is generative and closely intertwined with continuous human processes of reshaping meaning. So the second example that I've been focusing on to further develop this thinking is OCR-B. OCR-B needs to be considered in the context of a series of advances in data processing and storage, which occurred during the mid-1960s. In 1964, the IBM 2401 was released alongside the introduction of the System 360. The drive was the first to be compatible with new 9-track tapes, which remained the standard until the 1990s. The prior generation of tapes generally had a maximum of 7 tracks. So 8 tracks were used for data bits, each frame forming 1 byte, and the 9th for parity or error checking. The 9 tracks were closely aligned to emerging standards of ASCII text encoding. The original 2401 stored 800 bits per inch on each track, meaning that across 8 data tracks, 800 bytes could be stored. So in ASCII, the 800 bytes translated to 800 letters, which could be written or read from every inch of tape. The first edition of ASCII in 1963 used 7 bits to store each character, values from 0 to 127, with the remaining bit in the byte reserved for control flags or eventually extensions to the standard. So I've given the example of how the letter A is stored on the left here, and the table on the right shows the whole system of the original ASCII spec. So in concert with these advances in data storage, work was also begun on a typeface to optimize optical character recognition, OCR workflows, which would translate printed text into ASCII characters to be stored on magnetic tape. This was as part of a wider efficiency program designed to bring down the cost of OCR equipment by standardizing paper, printing quality, format, and typeface. Now known as OCR-A, the typeface was adopted as a US standard in 1966. Its letter forms were designed for machine readability, but this was largely at the expense of comfort to the human eye. To support algorithmically detectable distinctions between characters at high speed, continuities between letters such as B and D or C and O, which aid the human eye in holding words together, were compromised. Herbert Schantz, historian of OCR, commented that, quote, while not completely satisfying, the design of OCR-A was generally accepted by the users and manufacturers of optical scanning equipment in the United States. Europeans, on the other hand, found the design of OCR-A to be, quote, offensive to human taste. In 1963, the European Computer Manufacturers Association, ECMA, approached Frutiger to design an alternative. ECMA members agreed with the Americans that there was a need for a standardized machine-readable typeface. However, they wanted a more human-readable solution with the potential to be extended to incorporate diacritics and ligatures across multiple languages. Frutiger worked closely with ECMA engineers on a set of technical requirements. OCR-B, like OCR-A, was monospaced in order to be compatible with typewriters. Each character would need to differ from every other by at least 7%, and no character could be fully overlapped with another. Where OCR-A was designed to a 5x9 matrix, the Europeans worked to a 14x19 matrix, which would accommodate a range of scanning equipment while still allowing for sufficient space for details catered to human eyes. So here you can see an illustration of the matrix as well as some comparisons. As well as some comparisons with Univers from Osterley and Stam, who have a really good section on OCR-B. So with the release of OCR-B, Frutiger became an outspoken proponent of the need for machine-readable typefaces to also be considered from an aesthetic point of view. He argued that, quote, the computer cannot read, emphasizing that, quote, the computer does not use the same language as men. It cannot work directly with figures and with our alphabet. The computer, quote, knows but two units, impulse and lack of impulse. So following some fine-tuning and amendments to its character set, OCR-B was adopted as an international standard for optical recognition in 1973. By this point, most scanning equipment was capable of reading both OCR-A and OCR-B, and generally documents prepared using a range of typefaces and printing techniques. Frutiger's design for Univers had largely been concerned with the continued usability and possibility of the alphabet by humans at the threshold of a shift from mechanical to photographic typesetting. Even if the business case for its adoption as a standard was quickly superseded, OCR-B brought a corresponding set of concerns within the transition from photographic to digital typesetting. Media theorist Willem Flusser argued that the alphabet enabled humans to be able literally for the first time to think, where McLuhan and arguably Kittler held that electronic texts cease to be alphabetic once humans are no longer involved, once letters are converted to numbers. Flusser believed that letters and numbers belong to distinct symbolic systems. Numbers represent a structural, logical, and computational way of understanding reality, while letters are part of a linear, historical, and narrative-based tradition. Frutiger's approach to type design foregrounds specific characteristics of the alphabet: multiplicity, irreducibility to pure numeracy, continuous processes of making and remaking meaning, and open adaptability. Together, Univers and OCR-B also demonstrate the relevance of type design to the ongoing stewardship of alphabeticness in the context of the increasing prevalence of abstract and automated systems and the protocols which govern these. Inherent to alphabetic modularity is the enactment of a kind of anti-protocol, which refuses the techno-fatalism of control or total data integrity, which arises out of algorithmic modularity. As Flusser holds, the alphabet remains significant because it is not a protocol. Texts are half-finished. Their signs rush toward an endpoint, but pass this toward a reader who they hope will complete them. Texts are a search for the other. The alphabet, precisely because it facilitates communication imperfectly, holds space open for others, to add the plural to Flusser, and their yet undetermined futures. So that's it. Thanks.